isn't happening? I'm trying to record. There we go. Awesome, awesome, awesome. Okay. And we're back.
Cute little Susie.
Hold my hand. So, you totally should. Yeah. It's one for YouTube and one for just social media.
I think so.
Okay. Who really? Yeah, I'm honestly trying to figure out the best way to document this information because I want to be able to use it later for teaching purposes. You know what I mean? Test. Okay, let's see here. All right. Yeah, I don't know. Somebody check Instagram, see if it's like legit or not. Yes. There we go.
Says you're live.
It says I'm live.
It does.
Yeah.
I
Okay.
got the phone.
Oh,
solar
sweet.
phone.
Check it out. Okay, so we're going over here. This is actually okay, I actually made this document for a color theory assessment because I wanted to start seeing where. Is it working?
Yeah, it's
Oh my god. That was so pathetic. I'm sorry. Can you also check to this chat? Will you type something in there to let people know that we'll respond? Okay. Also, if somebody could watch on Instagram, that would be so helpful. If somebody leaves a question, I would totally want to respond to it.
I have it
I'll
on
do it.
this phone if you want to
Sweet.
use it. This one.
Sweet. Oh, here. Oh my god, so cute. Alright, hair color theory. Here we go. And we need to turn the volume down too, so.
That one I turned it off.
Awesome. Yeah. Alright, my loves. So this was a hair color theory assessment exam. So who had the question? The question. I was like, hold your question.
I said, I was asking for the K layer, like in terms of curly hair. I know we're doing color, but like curly hair is always really
More
dry.
riddle. You want to know why? I
Is
need
it
a
the K
whiteboard.
layer?
I have a whiteboard. You guys watch. Watch me right now. Boom. What is this? You guys, watch. Okay, so can someone bring me a towel?
Yes.
Okay, so we have polypeptide bonds. These are keratin chains, right? And these are the molecular bonds around those chains. Right? Boom, 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 boom. Okay.
You might have to turn it to that camera too, so that YouTube can see.
YouTube, can you see? So these are our molecular bonds of our polypeptide chains, okay? So these are made up of what? Hydrogen bonds, salt bonds, and disulfide. Do you guys remember that? Hydrogen, salt, and disulfide bonds. Those are the three types of bonds. Hydrogen bonds are broken and rebonded by hydrogen molecule, okay? So too much hydrogen molecule means it's wet. Too little means it's brittle and dry, right? Salt bonds are broken from pH. So if it's too alkaline, those bonds are broken. If it's too acidic, they will break themselves because they actually become rigid. And then disulfide bonds, those are broken through environmental exposures, color, thermal damage. That's usually what we are seeing the disulfide bonds from. So when we started coming out with products like Olaplex, right, they were the first product on the market that addressed something to repair disulfide bonds, because these are the ones that cannot be repaired. They can't be repaired unless we start adding in that biomimetic keratin. So biomimetic, and mind you, not every brand has biomimetic technology. Every brand that's like, oh, we're gonna add keratin in the hair. It could be all kinds of different forms of keratin, right? It could be synthetic keratin. It can be a keratin extract from like lanolin. I think those are the two most popular and common. But biomimetic keratin means that it's a keratin that has memory. So what happens when these little bonds get broken, right? Boom, boom. Right? These are disulfide bonds. Let's pretend that those are disulfide bonds. What the biomimetic keratin does is it comes in and it takes a look at what we have going on here, and it's like, oh, if these are circle, I'm going to be a circle. I'm going to fit in right here like a little circle, and I'm just going to go into where I belong. I'm going to find my place, and I'm going to mold into that keratin type, right? So it has biomemory is what it is, biomimetic. So having said that, how does that relate to this, the K layer, right? So for those of us who missed it, this is the actual diagram of a hair shaft. And these are not to scale, so please do not criticize me. I'll make that a little bit bigger. And then here's the keratin layer, or the cuticle layer. So Taylor, one more time, you were asking about the K layer, and for those of us who didn't see, this is the medulla, this is the cortex, this is the K layer, keratin layer or lipid fat layer, and then these are the scales that lay on that layer, right? Which are known as our cuticle. So what I was saying was when the hair shaft has the necessary proteins, okay, then we form the rigidity in the bonds to make them stronger. We can then start adding and injecting fatty lipid molecules that will plump this layer and bring health back to the cuticle that lays on the hair shaft. Okay, so we need keratin first to bring rigidity, and then once you have treated your hair with keratin, it's treated. You can't put more keratin in it. We're moving to hydration. Okay, so that is the series when we're talking about restorative, reparative health, hair health with our clients. Those are the processes that we need to be thinking of. Okay. How does this relate? So I'm going to actually skip past our color wheel, and I'm going to go straight into this. It says show the deposition of behavior for semi-permanent color on the hair strand. Show the deposition of demi-permanent color on the hair strand, and then show the deposition of permanent hair color on the hair strand. Deposition / behavior. How does it behave, right? So give me an example of semi color lines.
Semi and demi, I mix up a whole lot.
Okay, semi.
Semi just lives on the.
How about this? D for developer. Demi. Demis need developer. They need to oxidize. A semi does not. Sometimes they'll label it as a semi and use a developer, but you don't. And sometimes they label it as a demi and they don't need a developer. But the standard rule of thumb, and most brands will agree, that a semi should be something that is going to be living on the top of the hair shaft. So let's talk about our hair shaft and the behaviors of color. What, Lumi?
So, colorware, would that be considered a semi or a demi? Because it's not penetrating like a permanent, but it's not just sitting on top. It penetrates a little bit.
Okay, so I'm gonna divide this in thirds so you guys can see the behaviors between them, okay? So as far as alpha parf is concerned, there is a semi, there is a demi, and there is a permanent, okay? The demis are the colorwear and the colorwear gloss. The semi would be a direct dye. They call it
Like
Revolution.
the pigments or
No.
like that?
Pigments are a whole nother class themselves.
Okay.
The pigments that we have with the pumps, those have mimetic properties as well, meaning
Okay.
they mimic whatever you add them to. They adhere to the pH balance. They conform to whatever it is that the properties of whatever it is you're adding them to. Okay, so that's how we get them to add to color formulas without diluting them, is because it has that memory and performance there. So, but what we're talking about is deposition, behaviors of deposition. Behaviors deposit for color. So we have a semi, we have demi, and we have permanent. Okay? A semi, give me an example of semi color brands. What are some popular ones that we use for semi color? Pravana, yes. Fulbright, Danger Jones, Joico. All those things for vivid, direct dyes, okay? Semi-colors, they have like these obnoxiously large color molecules that like cannot fit into the hair shaft. So if we're lucky, we get it here, right? Or if the hair is really, really brittle and broken and dry, have you seen it drink it up, right? It's because the base of that semi-permanent or semi-color permanent color hairline has lipid fats in the base, and your hair is like
it's going into the K layer.
It's going into the K. It's going. I'm gonna cry. I'm so proud of you. Yes, it's going into the K layer. Okay, so it goes in here. When it's dry, right? And if it's super freaking brittle and broken, sometimes they come in here. Right, but we're gonna see them live here. This is the behavior of semi, okay? Sometimes, I have done this before, when somebody's hair is so fried, right? I have done my due diligence in putting a permanent color inside the hair shaft, but it is so fried that it's like still translucent. What do? I actually have taken Vivids. I've done this before. Taken Vivids, making a neutral tone. I custom crafted the thing. I made a neutral tone or whatever tone on tone that I was looking for, right? Looks like a natural shade. And I coated it, or I glossed it. I glossed the permanent color with the semi because that cuticle layer is so brittle and broken that it still looked dried and fried at the end of the day. Like, it was just like, okay, permanent inside, and then we're gonna put a semi on the outside and call it good, because she's gonna have to be back in 4 weeks no matter what to get her color touched up, because no matter what I put on her, it's going to fade. It's going to fall out because the cuticle is not there, right? We don't have the structural integrity of those polypeptide chains like I was talking about with those protein bonds that are connected. Okay, so here's our semi. Our demi is actually one of my favorites. My demi is like my go-to on so many different levels, but we also have to understand how it behaves and performs, right? So demi ideally lives here. There is some up top, right? Notice how they're like a little bit smaller, right? We can even get some into there, but we're living mostly around here, right? That's demi behavior. Now we have permanent color behavior. Okay, permanent color. This is a fun one. This is your medulla, right? Medulla, I want you to think about it as the center core of the earth. As you move into the hair shaft, those proteins become more compact. It's tight in there. There's not a lot of space, right? So, with our medulla and the behavior of our permanent color molecule, they live here and here, right? And we even get permanent out here, right? It's going to adhere to everything because it's tiny, it's small, and what happens is these bonds or molecules that penetrate the hair shaft have permanent that go into the hair shaft, and they find each other and they start sharing atoms of the same molecule, and they become bigger color molecules, and they're like magnetized to one another. I don't even know if that's a word, but whatever, we're rolling with it. They are magnetic, right? So they are positively and negatively charged. They start sharing atoms that loop around that molecule, and they become bigger and bigger and bigger, and they gather, which makes them permanent, which is why once this thing becomes a big color molecule, it cannot be ejected from the hair shaft. It doesn't work. It can't leave the hair shaft. It just became a big massive bond inside of your hair shaft, and there's no exit route because the tunnel they came in through was smaller than the tunnel needed to exit. That's why it's a permanent hair color. Are we understanding all this? We're cool. Everybody's following. Okay. Why is this information relevant? I started introducing this concept to you and Taylor like over a month ago, right? Talking about the density of the hair shaft, right? And how we can get the best performance of our hair color, right? Like I said, this is my hair shaft, right? And it probably is like that actually. This is my hair shaft. And if we're talking size comparison, this to this, right? If we're putting them under a microscope, I have no medulla. I have only a cord managed to be something around this size, meaning if we put a permanent on her, she has a lot of internal area to deposit this permanent color. Myself, if I tried to put permanent color in here, right? And I'm injecting all these little tiny permanent color molecules, I'm, in theory, going to receive and absorb fewer color molecules than Alexa could because of the internal diameter of the hair shaft. Am I talking above people's heads here? Are we tracking on information? Do we need clarification on any of this, on how this works and behaves? Okay. Especially for our reviewers, do you guys feel like this is a little bit more insight into how this all works? Are we getting clarity here?
Yes.
So why is that bad? If you put a permanent hair color on me and I absorb I have less deposition, less color molecule deposited into my hair shaft versus her hair shaft, that means if you put a level 6 on me with a 20 volume, it could potentially look like a 6.5 or a 7. If you put a level 6 on her, you're going to get a more true 6 because that color is living inside the hair shaft where there's more internal area to deposit those color molecules into. I don't have that space inside. So for myself, what I prefer to do, actually, I color my roots with permanent, I'm not going to lie, because Demi just doesn't agree with my scalp. It never has, and I have color allergies. But let's say if we're doing a fashion shade or a color correction or whatever it is, my mid shaft to ends, you would have to use a demi, a full coverage demi, which is one of the reasons that I love Alpha Carp, because not every color line can provide a full coverage in their demi line. A lot of demis are still translucent, right? They're still see-through. But if you were to put a demi on me, guess what? I have more external and outer hair shaft area to hold a higher concentration of color molecule than I would if we were trying to do permanent. Meaning a full coverage demi mixed 1-to-1 on my hair shaft at a level 6 is going to look like a level 6. A full coverage permanent mixed to your manufacturer's ratios or 1 to 1.5 on me is going to look kind of like a 6.5, 7 because I am absorbing less color molecule. What I'm talking about is the concentration of color molecule deposition. How concentrated is that color molecule in or on the hair shaft? I'm going to get better concentration here than I am with this performance here. Having said that, I want each of you to start thinking in terms of, does my client have a fine hair shaft? Does she have a thick hair shaft? Is she brittle or does she have elasticity? Is she hydrated, right? Is she breaking? Does she need protein? Or is she just dry, right? There are ways for us to figure this out. So in combination with all those things, we can start diagnosing, I'm going to use a permanent on her, or I'm going to use a semi on her, or I'm going to use a demi on her because I need to get the best performance of this color line right now. When they walk out the door, it's got to be perfect. And I'm going to eliminate variables. Like 9 parts of our job, 9 out of 10 parts of our job is just eliminating variables. I'll be honest. That's why we do a lot of CPRs, hair prepping, and that's why I use a color line that's very plug and play. You get what you see, you get what you pick out kind of idea, because I want consistency and dependability in our results. When we understand how I see your hand, hold it. When we understand how the hair shaft performs in absorbing and receiving color, we're able to make better choices at that point. So, the concept for deposition concentration of hair color molecule is the same as taking this much water and putting a vial of blue dye in it, and then taking this much water and putting a vial of blue dye in it. It's less concentrated in more water, and it's higher concentrated in less water. That's the idea. It's going to be higher concentration on someone like Alexa because there's more space to put that dye molecule into. It's going to be less concentrated on someone like me because there's less space to put the dye molecule into.
Is it?
Wait, she had a question. Hold your question. What's that?
Not like a question, but I was gonna ask if you could like quiz like two of us and see like give us like a fake client and see if we know what to put on.
Absolutely.
Yeah.
Absolutely.
So go ahead, hit me. Let's see if I.
Well, I have an area at the bottom where
Okay.
we're gonna write out some formulas. So remind me to ask you that
Okay.
question.
Just
I'll
okay.
give you I'll pull something up online. We'll look at a visual, and you're gonna tell me not only what formula you think it is, but you're gonna tell me whether you're gonna use a semi, a demi, or a permanent. Okay. Are you guys good with that? Is my phone still running? Right here.
Yes.
Okay.
Wait, really quick.
Yes.
So, let's say that you are doing a demi that has thinner hair. Since it's a demi and it's not penetrating all the way, it's more so
More external area.
external. Is it a thing that they might find it fading faster than if they used a permanent? And could you, if they did feel that way, could you use a permanent but just use less developer so
No.
it's more concentrated?
We won't do that. We won't use less developer because to make a formula more concentrated when using a permanent, because we will always follow manufacturer's instructions. Okay. We will always follow manufacturer's instructions. If somebody's hair gets messed up in this salon, I'm going to ask you, did you follow manufacturer's instructions? Because if you didn't, no longer do you not have a job here, but now I have to cover for a mistake that could have been avoided, right? So manufacturer's instructions are very important when we're learning and understanding how color performs and behaves if you want consistency. Having said that, tell me the first part of your client. If you're afraid that the demi would fade sooner than the permanent,
Yes.
that really comes down to performance of the color line. For me, if I'm
Okay.
afraid that the demi is going to fade sooner, I actually will bump them to a 20 and do a 1-to-1. And that will give me full 100% gray coverage, specifically with this Alpha Parf color line, right? A 1-to-1 with 20. In this color line in Alpha Parf, you can mix a 1-to-1 or you can mix a 1-to-2.
And would
Those
the
are your options.
20 be like it's lifting and depositing, or is
Semi,
it
yes.
Kinda.
Yeah,
Okay,
you're just
okay.
getting more available space, open space from the cuticle. When I do this means cuticle's opening. It's just, can we just keep that as like universal? When I do this, it's open cuticle. When I do this, it's closed cuticle, okay? Let's just get that right up front. So yeah, it gives you more available space to put the color molecule into.
Okay.
So the 20, I have not seen fades any less or any sooner than a permanent, okay?
That's what I did on my client. Just the other day.
And you were like,
And
why
I
are
did
we
20.
using a 20? And I was
Yeah, I
like,
did
because
20.
we want it to stay.
Yeah.
And you're getting a full deposition color, meaning we should not be concerned about warmth or translucency underneath. What I was trying to explain to Stella the other day was, hey, with this specific color line, if you use a 20 at the root to cover gray, and then in the same formula use a 30 at the root to cover gray, and lift natural at the same time, what you lift with the 30 isn't going to look brighter or lighter versus what you lift with the 20. Why is that? I know. So tell me, why is that? It's because the color is still depositing at the same level. It doesn't matter what color is underneath there. You're getting full deposition, full coverage with a permanent color. Mind you, the permanent lives all the way up to here, right? So blah, 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 blah. And yes, you're not going to have more translucency. You're going to have the same level of deposition. So that should be what we're thinking of. If you put a 40 on the mid shaft to ends, and what you need to do is lift virgin and deposit color at the same time. Let's say you're going from a 5 to a 7 and you want to use 40 mids to ends, or even 30 would work. You aren't going to end with a dark any other factor than whether she had permanent hair color underneath that or not, right? So if in theory, not that I would, if I used a 30 volume to get from a 5 to a 7, I'd have the same level of deposition as if I used a 40 to get from a 5 to a 7. Okay, we're tracking so far. So we all understand the behaviors of semi, demi, and permanent hair color, correct? All right. All right. Let's move on. This is one of the things, the biggest points that I really wanted to cover with you guys, because this helps us in the primaries of finding and creating formulations. Primitive primaries is like not redundant at all, or whatever. All right, let's talk about our color wheel. I feel like this is something that we should all be proficient on. Color wheel. But what I am going to explain to you, which you probably don't know yet, is the difference between a neutral, a natural, and a warm natural. I'm sorry. Yeah, warm natural. Neutral natural and warm natural. Okay? So we have our color wheel. Right? Okay, red, blue, yellow. This. Do you guys know yellow green is actually called chartreuse? Yeah, we have a reel about it. Look at that bone charger right there. Behind you. Is that yellow or is that green? Tell me.
This?
Yeah. Is that yellow or green?
It's green.
What color? I want to know from all of you. What do you think that is? Yellow or green?
I feel like it's green.
Neon.
It's a line.
Would it be neon green or neon yellow?
I don't know. You tell me.
That's gross. I don't like this question.
You tell me. What is it?
I don't know where to put things. I feel like I'd call it neon green.
You call it neon green?
Yeah,
Someone
I
else would
think.
call it neon yellow? It's chartreuse. It's literally like the trickiest color to figure out.
So that's even four line.
Okay.
Wait, red orange, yellow orange,
Yes.
yellow green.
I want you guys to start thinking these in properties of one. Okay, so ratios is essentially what we're going to be discussing right now. Okay, we're talking about ratios. These dots represent color molecules. What's that mean?
I'm sorry. I'm so like, I'm trying to put the color wheel together, but I'm like,
Wait, I think
You're
I'm
struggling
it's
or what?
because you wrote it on that.
I think I'm wrong.
Yeah, I feel like I'm putting them in the wrong order.
Because there's two
Oh.
in spot.
Oh, wait, we got.
Did I get it wrong?
No, I missed the O for the orange.
I get it.
Red,
Those are your primaries.
red, orange, then orange.
So we have blue, red, yellow. We have green. We have, oh yeah, that's, wait, no, that's right. Yeah, that's
Oh,
yellow,
you're
orange.
right.
Yep. Orange. Yeah, green, orange, violet, right? And then from there we have our tertiaries. Yeah, no, that's right.
I just.
Somebody
I was
correct me
having
if
a
it's
tough
not
time.
right. Does somebody correct, I need someone to correct me online if it's not right.
Is the BB above the B?
It's the BB, and then it's B.
Oh,
Then
that's
it's
where.
blue green, then it's green, then it's yellow green.
You know, it's right on my other page.
Yeah, these are your primaries right here.
Oh, because of violet. Yeah. That's what happens when we don't have like indicators of where we're going.
I gave you a circle map and you started filling it in order and it was like, wait, where do all the other colors go?
Literally.
Yeah,
And
that's
so
what
we're
happened.
missing a lot here.
Should I just draw straight on here?
It'll come right.
Okay, so you guys, I want everybody to look at this. If we're thinking about properties of ratios, we talked about this last week. Can someone tell me what this is? What does this mean?
Oh, colored deposits?
We're talking about concentration of deposition. Yes. We're talking about light reflection is what we're talking about here. Okay? So we're talking in the idea of ratios. So one blue color molecule, I'm going to use the word molecule as a flexible term just so we have something to pin it to in our brains. One blue is going to be as strong in deposition or light reflection as 2 red and as 3 yellow. So if you want a full true neutral and you want your colors to truly be in equal parts when making a neutral, you need 3, 2, and 1. Have you ever tried to mix blue, red, and yellow together in equal parts? What does it make? Gray.
Yeah.
It's cool. It's almost purple,
Yeah.
right? So,
Almost like a
yes. Cool, natural. This is a warm, natural. Wait, no, this is neutral. Yes, this is neutral. Well, not, let me write this out so I don't mess you guys up. It's yellow. Full natural. This is neutral. And more natural. More natural is. Hold on, I'm making sure I got this right. This is more natural. I'm an idiot. There we go. And then this is natural. There we go. Natural, cool natural, warm natural.
Natural or neutral?
I'm sorry.
Or neutral?
Warm. This is neutral. Wait. Hold on. I'm confusing myself now. Maybe it's because I'm writing it backwards. Cool natural. Boom, boom, boom. Neutral is this. 1, 2. Hold on. 1, 2. Yeah. Neutral. There we go. Warm natural. Okay. So we have cool natural, we have warm natural, and then we have neutral. Do we see how this would be more dominant than these, overpowering the color, making it more of a cool natural? Do you see how blue? Because it's the darkest of all the color molecules. It's going to absorb the most light. Okay, it's going to be most light selfish or light hungry. So this, when we mix paint in equal parts, blue, red, and yellow, we get something very gray, right? Very purpley. We've all done that, correct? Or do I need to start giving paints out because I can do that? When we actually mix them in what would be considered equal parts, so that way they also all have the same properties as a level playing field as far as light reflection is concerned, we start getting that true neutral, okay? And then this is warm natural. All right, you got the color wheel?
The neutral natural makes more sense actually.
Yes. I was literally confusing myself. I had it backwards for a minute.
Yes.
So I had to double check, and I can Google it just to make sure.
Like it's almost like natural is like the tone that you're looking for, and neutral is where it's like all it will come out as a normal round. There we go. Really like to make them.
Oh my god, I could be a ring girl, but for hair color battles.
There you go.
Okay,
When you're ready, we're on to the next.
we're gonna, I don't want to do label the dominant pigments. Honestly, I feel like that is a conversation with a theory that we can have another day. I do want to label the numerical values, you guys, just to give you the cheat sheet. And then I want to talk about some formulations, okay? So this is a concept that I really want you guys to understand. All right. these are the ones that you need to know. These are need to know. And this is not a direct translation into every single brand. Some brands swap them up. But internationally and in 80% of the world, as far as hair color is concerned, these are internationally recognized numerical values for tone. Yeah. Yeah. Okay, this is the concept that I want. And have you guys ever wondered how somebody like myself or Amanda or whoever, we go back to the color bar and we're like, oh, if I featured, that'd be gorgeous. Or, oh, like a 6.1, yes, that's what we need. And it's just like, honestly, it's a language. The more exposure you have to it, the more immersion you have in it, the more you see in number, right? You're like, see the tone in the number. This is a concept I want to introduce to you guys that I feel like is most important. What was the question?
Does that say matte/green?
Matte/green.
Okay.
That's what I was gonna ask.
Matte/green. Green is actually so important. So important when coloring hair. It is the underdog for sure. It is the underdog for sure. I love green for so many reasons. I love green and copper. Oh my gosh, you want to know why? Because this cowboy copper that we have floating around, you want to know what that is? That has green in it. You guys want to know why it has green in it? Because it's not translucent. It's a natural copper tone. We need the green to cancel the red to make you look not like
super red. Not
Ronald
fire.
McDonald. Exactly. You need the green to cancel the red to make you not look like a fool, right? We don't want translucent hair if we're going for cowboy copper. We don't want fire engine red if we're going for cowboy copper. We don't want orange or bright Halloween copper if we're going for cowboy copper, right? You guys see how these trends, and that's why we were missing the mark so much on like the industry, not us. We're perfect. But the industry was missing the mark so much on the cowboy copper, and that's why it became a phenomenon, just because the average stylist couldn't figure out how to formulate for it. Well, it had a neutralizing tone in it, which was. Let's talk about how this affects you. We're going to talk about the concentration of pigment in the numerical labels. Call label. Wow, I don't think I spelled not one of those 6 words correctly. I spelled of correctly. It's fine. It's fine.
It's the one that I messed up.
It's fine. Okay, so what I want you guys to understand here. So if we're looking at what is that? It's a neutral brown. It's a natural brown, actually. This is going to be the warmest as far as alpha parf is concerned of the natural browns. Okay. What is this? Yeah, it's 8. It's 8 cool natural is what alpha parf refers it to. And remember this, ladies, alpha parf performs cooler than any line that you will see in a very natural way. Not a green way, not a blue way. It is cool. I do not get hot roots with this brand unless it's my fault. Okay? So this is an 8 cool natural. What is does anyone know what this stands for? Natural intensity. Okay? So 8, in fact, 8NB and 8. So this is a and this is a so it's cool, warm. Your head just almost fell off of you're like, what? Okay, is this making sense to you when I just introduced that concept prior?
That BRY, the thing you do, that part makes
Yes.
everything just so.
This is
much
ratios.
Yeah.
This is ratios. This is ratios. We're talking about color and ratios, okay? The volume, the amount that you mix can stay the same, but the ratio of color does not change, right? We could have 300 grams of color or we could have 5 grams of color. The ratio is the same. This is a ratio, right? So this is how our cool natural is made. So this is blue, red, or yellow. This is how our natural Bahia is made. Blue, red, yellow, yellow. Right? And then this is equal parts. Exactly. This is why it's so cool. is because blue is darkest. This is the show hog right there is the blue.
Which line is it that uses the letters also? In
I don't
Alpha
Oh, it's probably Precious Nature or something like that, which is like a hypoallergenic, but we don't
Okay.
carry that.
Because usually they're all numerical, right?
Usually.
Okay.
Usually, yes. Okay. So, now that we understand this, I want you to see this. If this is our 8NI, that just means 100% of the formula looks like this. Right? That's 100% of the formula. As soon as we add this, let's go back. As soon as we do, 8, as soon as we give you that, okay, what does that add? That adds ash, right? This is an ash. How much of the formula is ash? And how much of the formula is cool natural?
A majority is ash, because it's the first number, or it's the only number after the decimal.
Is it the majority? It's 50%. It's a trick
I was
question.
gonna say I was said 50, but
Okay, it's 50% because these two missing decimal places are not there, and they are the blue, red, red, yellow, yellow. So it's 50% ash, 50% cool natural. Okay, once we move into this, let's put in another placeholder. Let me move this over, my shitty writing here. How much of the formula is violet now? So we know 50% is ash. Then how much of the formula is violet? Because it's the secondary color. Do you remember from last class?
Is it 25?
No.
I was gonna say 30.
Because it gets
Okay.
less and less and less, right? So, but I know what you were thinking, but you
Yeah.
were thinking in the reverse.
Okay.
Yes. So this is 30%. Okay? Which means how much of the formula is left? We have 50% here, 30% here, then this has to be 20%, correct? So that means 50% of this formula is ash, 30% of this formula is violet, and 20% of this formula is a cool natural.
How do you know that it's a cool natural even though there's no number there?
Because that is cool natural. They're like anytime you see an 8, a 6, 5, 4, whatever it is,
Okay.
in Alpha Park, it's a cool natural.
Whatever. Okay.
Yes.
Okay.
The only way you're gonna get or it's actually that's their neutral.
Mhm.
The only way you're gonna I keep saying cool natural. I'm so sorry. Am I confusing you? This. Oh my God, I gotta go back now. Whoa! Who wrote it down? Because
That is the neutral.
neutral. Yes. Yes. Okay. So this is their cool natural, or this is their neutral line. This is their neutral.
Which their neutrals
Is cooler.
are cool.
Yes.
Okay.
Yes. No. This is it. That's it.
Yeah.
Okay. Somebody correct me, please.
That
My
is-
brain isn't perfect, but
No, that's
I'm
it.
doing my best to rudimentarily communicate these concepts to you. Yeah, so this is their cool natural. Boom, boom, boom. 1, 2, 3. That's their mixing ratio, cool natural, right? And why is it cool? Because blue and yellow make green, yellow and red make orange, and then you have yellow and red. So you have one green color molecule, you have one orange, there you go. 1, 2, 3. So you have everything in the wheel. So this is their neutral. This is their very neutral. So 20% of the formula is that. So are we seeing this concept though that how as we move down the decimal system, that number represents a smaller concentration of tone in that formula?
How do you get like the point? Like if you're measuring it out, how would you get 1 point? Like
Go-
0.12 something.
Any other questions?
I really have questions, but I can't feel my feet.
Well, we're almost done with this.
It's okay. I ain't moving.
And we're talking formulations.
Should I show you my workbooks from school? They're
Yes.
not this in depth.
No. Mm-mm. They wouldn't be. They wouldn't be this in depth.
Good thing I saved them all for text.
This is a legitimate. Okay, because here's the thing: when you start getting into advanced color theory, it's a theory.
Mm-hmm.
Like, we don't understand. It's not always 100% widely recognized by every single brand, by every single colorist, by every single chemist, right? We can do our best to take math, science, and obviously case studies and results and create a theory as to why we think it is the way it is, right? When you're in school, they have to teach you what they know as fact and widely recognized as factual information. When we get into advanced color theory, it is a theory. That is why these classes are harder to come by. Mm-hmm. And you need to find a stylist who aligns with a brand that has the science to back it up, right? Which is one of the reasons that I love Alpha Parf. They're the world's largest distributor of color. Manufacturer of color. They understand it. Not only do they understand it, they set the precedent on it, and it's their science and their patents. So yes, this is fine. That works. 832 or 632.
632.
That's a 632, right?
Yes.
So repeat your question to me one more time. How do you make? Are you asking me how you make these formulas?
Guess I didn't realize that it comes in decimals already. Like, part of me was kind of glitching out on that. So I think in my head I was like, well, how do you get a 0.32 after like your level?
I'll also tell you there's a hack to this. So if we know 50% is gold and 30% is violet, it's frustrating for you guys because it's like we're not only taking advanced understanding of knowledge, now we're making it even more complicated, right? And you're like, I'm not learning anything anymore because I don't understand the fundamentals as to why you can make a 632, right? Okay, so if we made a 632, I could do something like, I know 6.3 would be 50% of my formula. I know 6.2, we don't have a 6.2, but I'm just saying for theory, if they did, this would be 20% of the formula, right? And, or I'm sorry, 30% of the formula.
Or you could do a five.
Tell me,
What are we making?
if we're making a 632
We're making a 632 without having a neutral.
without having a 632. So this would be 50%. That would be 30%.
What if you did?
I'm making, so what I was proposing to them is we could use 50% 6.3, 30% 6.2. Even though Alpha Parf doesn't have a 6.2, I'm coming up with a theoretical solution. You know what I mean? So, and then 30% 6.2 and then 20% 6, right? So that's how we could make this number right here, essentially, is what we'd be getting.
Could you also use like the pigments? The pigment
Oh, that's what.
lines
Because
We
you
could.
could use violet and.
Oh, instead
Oh.
of using like the 6.2, since there's no 6.2, you could use the violet.
Uh-huh.
So you could do like a 6 with.
Mm-hmm. And that would have to represent 20%, or I'm sorry, 30% of that formula. Yeah.
Could you give an example of how much, like how many ounces in terms of what it would look like at 50%? What would it look like at 30?
Okay, so this, if we're gonna talk grams,
Yeah.
because it is the superior way to measure color, and if anybody disagrees